liquid separator, a series of vanes or louvers in the filter circulates the air in the first stage.
So it helps condense any remaining water vapor or moisture in the air.
Second stage, the air passes through a screen of sorts, called an element, in order to catch unwanted debris. Once dried and clean, it is common to adjust the level of air pressure coming out of the compressor.
What happens if you got debris in the air?
Scratches.
Yeah. And what does it cause? Clogs and damage the seals in your pistons, air tools.
Adjustment has an impact on how much force the system generates. Higher pressure allows the actuator to put out more force, and lower pressure creates less force. The regulator achieves this using a spring-loaded assembly. The knob on the regulator adjusts the force of the control spring to achieve a desired pressure setting.
You know how a regulator works? You got the diaphragm.
Whenever the downstream pressure level drops lower than the desired set point, the poppet, or internal valve, opens a pathway for the higher pressure upstream to flow downstream. This continues until the pressure in the system reaches the regulator's set pressure. At this point, the poppet or internal valve closes until there is a new downstream demand. It is also common to have a pressure gauge on a regulator, so
it's a pretty, it's traditional, it's mechanical, but it works amazingly. This regulator mechanism. You got a big diaphragm, you got a spring load, and so how much you press will control how much air it allows to pass through. And so it's self-regulating, a regulator.
the user can monitor downstream pressure. Finally, in specific applications, such as air motors or pneumatic tools, a lubricator can be added to distribute a fine mist of lubricant into the compressed air to help lubricate downstream components. Now that the compressed air is clean, dry, and set to the correct pressure for the application, the next step is to direct it where to go to create motion. A directional control valve is used to achieve this task. This directional control valve has a series of internal pathways that can connect the air coming into the inlet port with one of two avenues to leave the valve, called...
So, what kind of valve is this? A 3-2, 5-3. You remember all that? What?
How to read pneumatic valves?
The first number is the number of?
The number of ports.
The number of ports. Well, the second number is?
The number of
Position. Right? A two position would be like A or B. But what is usually done with the middle positions when you have a 5-3? Like the neutral position, now you have different options, right? Some of them basically close all ports. Why do you want to close all ports? You want to hold the position, right? You cannot move the cylinder. In other words, it's not back drivable. So you cannot, any load out there will not push back your piston. But sometimes you want a neutral, meaning a free, open port position, which allows it to freely move.
Working ports. Depending on the position of the moving element, which is typically called a spool, the air will be blocked from traveling down one pathway and allowed to travel down the other. The high spots on the spool, called lands, will block the air from proceeding down one path, while the lower sections on the spool, called grooves, will allow air to flow around them and proceed to one of the working ports. In this common type of valve, when the unit is not activated, the spool is forced to the left side of the valve by a spring. In this position, you can see that this land blocks air from going out the number 4 working port, and instead is forced to go out working port number 2, because the grooved lower section of the spool allows air to flow past it and out to the number 2 working port. In order to change the direction of the air to the number 4 working port, the valve needs to be turned on. In most automated equipment, a PLC, or programmable logic controller, will instruct the valve to shift using an electrical signal. When the signal arrives at a portion of the valve called a solenoid coil, A magnetic field is created that pulls a cylindrical piece called a plunger towards it. When that plunger is unseated, it allows air from inside the valve, known as pilot pressure, to push the spool to the right. Once the spool reaches the far right side of the valve, the lands or high spots are now closing off the passage to the number 2 working port, and instead directing the compressed air.
Okay, so let's skip that. You basically know what's going on. So these are the cylinders then. There are many types of cylinders depending on your applications, but this is the basics of how it
Into the
works.
cylinder. When the compressed air pushes on the piston, it is forced to move forward inside a hollow cylinder that is commonly called the body. The piston is attached to a rod that will extend as a result of the force generated by the compressed air.
So the force will be equivalent to the pressure multiplied by F is equal to P times area of the piston, the round piston here, right? The retraction will have less area because of the rod.
On the piston, the actuator will continue to move in that direction until it reaches its physical limit, or if the force resisting motion, commonly called the load, is higher than the force of the compressed air, in which...
Okay, so that's kind of how it works, which is not the focus. So let's look at the different types. I don't know, did you discuss this in pneumatics last time? The different types of cylinders? You remember 2 years ago?
The cylinders?
How many of you are semester 5 students? Okay, so it's just last semester, right?
But 2 1 way, that
2 semesters ago?
Yeah.
Semester, third semester? Who taught that? Boris?
Yeah,
Yeah.
actually one.
Did we go through the different types?
Spring,
Okay, okay.
This one with the mat. Yeah, with those dampeners.
You go through like rotor cylinders and all that?
Yes.
Yeah? Okay, so this is a catalog from SMC, which is one of the most common brand world leaders. Let's see. The valves here, the actuators. Let's look at that. So you got compact ones, short stroke, mainly for clamping, not for stroking like pushing a long distance. This is the standard ones, water resistant, rodless. What's the advantage of a rodless cylinder? Instead of the usual air cylinder. No idea? This is a standard air cylinder with a piston and a rod. So let's say you want to move an object from A to B. So at the extended condition, what's the length? 2 times the stroke at least, right? If not a bit more, because you need this dead space. But with a rodless cylinder, you got the carrier here, move from A to B. Do you see the difference? You got the piston here, moving inside. So what's the advantage? Compact, right? So here, whenever you want to move things or actuate things, you need as much space in the back as your stroke. And it becomes an issue when you run out of space and long stroke.
Wait, how do they seal that? Bellows?
No, there is a flap that it's hard to describe.
Yeah, how do you that seal is gonna be really expensive. Oh, how do you seal
No, it's not that bad actually.
Yeah, where do you put the seals for it to be able to?
There are two kinds. One is magnetic. So the rod, the piston is actually magnetic, and the carrier is driven wirelessly without any mechanical connection. But you can have a decoupling. So it's limited by how much load you can have. But the other one is, it's not magnetic.
Horse with an outer shuttle. Now, let's look at the internal structure and operating principle of the rodless cylinder in animation. First, let's look at the internal structure of the rodless cylinder. When only the typical parts are explained, the rodless cylinder has a cylinder tube, a shuttle, a piston, an inner sealing band, an outer steel band, and end covers with air cushions on both sides. The description on the cylinder tube and the end covers on both sides can be found in the previously uploaded pneumatic cylinder-related video. Then, let's take a look at each part of the rodless cylinder. Now, there is a piston. The piston makes a linear movement on both sides by the compressed air supplied. The shuttle, which rests on the piston, moves with the piston. The cylinder can be connected in various ways. Like this cylinder, the piston and the shuttle are directly connected together. And the magnetic rodless cylinder has a magnet attached to the magnetism between the piston and the shuttle.
Okay, here goes the sealing band.
The internal sealing band is installed directly above the piston to prevent external leakage of internal air pressure. As its material, an elastic and durable material, such as polyurethane, is mainly used. Above that, a magnet mounted on the top of the tube helps the steel band stay in close contact with the tube. And the steel band is installed at the middle. From the shuttle end caps prevent dust from entering the shuttle from both sides and flattens the steel band. The end covers are fitted on both ends, and finally, the steel band fixing bracket screws are tightened to prevent the band from being deviated.
Oh well.
Deviated. Oh, wait.
Here. So the pink is the sealing band that kind of, you slide on it.
So there's like the polyurethane one at the bottom and the steel band at the top.
Right.
They kind of, okay, so it kind of. Wait, so it folds or? It just bends.
It's flexible.
It's flexible. You can compress it that much? Steel band, yeah.
It's like a thin steel band.
In pneumatics, cylinders belong to the most important.
Have you not? They could like a saw and
Yeah, I know, but compress it.
Here,
like
the
if
piston is
it's
mechanically into the
compressing
carrier.
it like.
And in that
yeah, I guess it gets harder at the end.
fan heats the air within the barrel of the cylinder. But how so? As the piston drives, the two band sealing strips open in front and then close behind, regardless of the direction of travel.
Yeah, it slides along.
Yeah, the band stays in place.
The band stays in place.
I thought it's fixed.
No.
No, because then it won't be a rod. That band becomes a rod.
Yeah. That's what I'm confused.
Yeah, starting to make sense. Kind of. Hard to understand at 3 p.m.
The seals of the piston inside the cylinder barrel press the inner band tightly against the barrel of the cylinder, preventing air leakage. The outer band is pressed tightly against the outside of the slot of the cylinder barrel with the so-called shoes of the carriage. And it's working. Here you see a band cylinder totally dismounted and fit together again. Inner and outer bands may wear over time as they stretch.
So the rubbing or the sealing is between the seal ring and the sealing bed. Okay, and that interacts.
Result, you can get air leaks and loss of air pressure. It is up to the maintenance to replace these bands, especially for expensive cylinders. The last type of rodless cylinder is the so-called cable cylinder. Here, a cable is connected to the piston and drives the carriage through a pulley on each end.
So in this case, the seal is here. I don't see this too often though. I mean, is there a tiny leak? Yes, there is a tiny leak, but it's insignificant compared to the advantage you have, okay?
This is a very simple design. That's why cable cylinder, the main sleeve first extends. Three-cylinder converts compressed air pressure into a rotary
So here's a cylinder with rack and pinion.
motion. One of the most widely used designs is the rack and pinion rotary actuator. A long piston with gear rack teeth meshes with a pinion mounted to an output shaft. The output shaft of this double-acting cylinder rotates counterclockwise by pressurizing the right-hand chamber. Compressed air on the left-hand chamber produces clockwise rotation.
So, I mean, it's a regular air cylinder, but the rod is a rack.
Pinion rotary cylinders offer a wide range of torque and rotation. They are mechanically stable and provide radial load support. Vane cylinders have a cylindrical chamber in which a vane is mounted to a central shaft. Air pressure on one side forces the vane to rotate until the end of the stroke is reached.
This is another type of rotary air cylinder. You got the vane sweeping, but you don't have full rotation then because you will need the port. Let's see. Here is a 4-position indexing.
Welcome to video tutorials of mechanisms by Mikonis Muller. If we want more than 2 positions for the indexing, up to 4 indexing, we should use 2 air cylinders with different stroke sizes as shown here. If we want the indexing distances to be equal to each other, then the stroke of the long cylinder should be twice as long as the short cylinder. Notice that with 2 equal stroke cylinders we can only get 3 indexing positions. Here is the assembled view of the cylinders. The short and long cylinders are joined back to back and the short cylinder is tied to a wall with its piston rod.
So this multi-position cylinder is basically 2 air cylinders back to back. Okay, and you hold them at the rods. Look at what happens if you pressurize the different chambers.
The long cylinder's piston rod is fixed to a slider mechanism which will push workpieces to a predetermined index position.
These are the
In this animation, the stroke of the small cylinder is 100 units and the long cylinder has a stroke of 200 units. This makes indexing positions 100 units apart, as we will see soon. The green arrow shown here indicates the indexing positions. The vertical red and blue lines are pneumatic tubing where blue indicates low pressure while the red indicated high pressure. Notice that both cylinders are in retracted positions and the indexing head is positioned in the initial stage of indexing. 2 cylinders are controlled by their own 4-way solenoids valves not shown in this animation. To reach the first indexing position we should extend the short cylinder. We accomplish this by energizing the short cylinder solenoids.
Okay, so the short cylinder moves, but not the long one.
To reach the second indexing position, we should extend the long cylinder and retracting the short cylinder at the same time. The
Okay,
final indexing position
so this one, the long cylinder is actuated, the short cylinder is retracted.
can be reached by extending the short cylinder and keeping the long cylinder in its already extended position.
Okay, so there you have it, multi-position air cylinder. Now, it is not continuous, you cannot stop at anywhere you want. you have to predetermine it ahead of time. But this kind of signifies the different ways you can manipulate. Oops, not this one. Where is it? So this is the pneumatic indexing. Okay, so the use is you can distribute these in a rotary table without all the jumbling benang kusut, all the holes. Okay, that's a nice port you can do. So there are many rotary index accessories that you can use. And I think I displayed this one. This is an actuator which has feedback.
I'm JD Stelter from the Electrical Engineering Group for SMC, and I'd like to show you some of the details that make the MPC a great product for the controllers that go along with the electric actuators. All you need is air, power supply with 24 volts, and an analog input signal. The position of the MPC correlates with the input signal. Assuming you are working with a 100mm stroke, and you're using
You can determine where you want to go by regulating the air pressure.
a voltage signal as your input, you have an input of 2 volts. There's no adjustment for acceleration or speed, which makes the setup and operation easier.
Okay,
External
so
force is applied, which is stronger than
that's kind of a position feedback variable piston. All right, so any questions before we do the final the post test? No? All right, go ahead and redo the post test from the Google Classroom, and we can call it a day. Same link, just use the same link.
Sir,
Yeah.
15, it says which one of these motors has high reliability, but you can pick more than one. I'm not sure. You should pick one or like.
The last number?
What? Number 15, you can pick more than one. So
Yeah.
Okay.
Sir, do we mark it as done?
Sure. You're done? Anybody not done? Raise your hand. Okay. Hurry up. Okay, everybody submits already? Are we good? Okay. All right. Okay, see you guys.
Internship. Tapi kalau gue kompetensi itu sebenarnya ya komik karena safety issue.
Mau makan sudah ya?
Saya dulu. Itu saya minimal.
Makan biar guna gue selamat.
parts.
Bisa yang interaksi bisa.
Udah gue gak bisa selamat cek wassalam dulu. Set. Allah anjing ngapain itu? Boy boy. Pinggir lah. Pokoknya udah gue aja.